universal library, automation, continuation. While the ultimate in automation is the fully automatic factory, it should be remembered that automation involves no mechanism capable of original thought, but merely the coordination within a man-made scheme of a number of techniques which have evolved in the course of developing mass and flow production, accurate gun laying, telecommunications, and the mechanized analysis of statistics. Oil refineries in the 1920s began to extend the use of instruments for controlling chemical processes and rapidly attained full dynamic equilibrium in a continuously operating plant where fluids, gases, and even some solids are pumped continuously through reactors and vessels into final product storage. The only human intervention being to check product quality and adjust controllers to give optimum overall efficiency. Some too many may suffice to run £500,000 worth of plant at full capacity, but there may well be 30 or more maintenance and ancillary workers for that unit. Only technological difficulties concerned with continuous chemical analysis and with dynamic characteristics of chemical plant prevent the achievement at present of full automation in the chemical industry. However, these barriers are unlikely to remain for more than 2 decades. In the mechanical industries, the manufacture of motor cars offers fertile conditions for the application of automation, and the automatic movement of an engine block casting from one automatic machining operation to the next with automatic inspection of the work through to finished assembly without human intervention is practiced in several countries and was pioneered by the Austin and Akdal companies around 1926. The basic essentials of automation are: A. Servo control mechanism with feedback for accurate positioning of workpieces, valves or effort devices. B. Sensing devices for measurement and conversion to digital or analog signals. C. Transmitting and recording equipment for the marshalling of the signals. And D. Computers for treatment of these signals according to formulae or instructions previously inserted into them by human planners, and producing further signals to initiate through A. The servo mechanism the appropriate action in the plant. The justification for the heavy initial outlay in development and plant required in the adoption of automation lies in the significant reductions in cost per part produced, namely saving in direct labor cost, economy in floor space, often 25–50%, lower stock of work in progress, much greater control of processing and hence lower wastage and less rejects, simpler and hence cheaper operating hands-on machine tools, automatic inspection of the workpiece with feedback corrective controls, and much fuller utilization of the machine capacity, which lasts in both the mechanical and chemical industries, shows the greatest saving compared with the social upheaval of the 18th century. The advent of automation in a society already conditioned and adjusted to technological change is unlikely to produce any significant unemployment or unrest. It is true that any industry adopting it will be faced with problems of displacement and training, but generally speaking, the total number of employees will not diminish, although the skill demanded will be much higher. The product output will increase and the unit cost will decrease. The increased quantity at lower cost is presumably the economic reason why a concern will elect to adopt automation, while rehabilitation and upgrading of personnel pose management problems. The newly created tasks demanding quite high grades of skill and mental alertness should prove more interesting and satisfying to the worker than do repetitive work. With skillful handling, there could develop a situation in which the shop floor to management relationships become more harmonious in a climate in which interest stimulates pride in workmanship